Kia ora. Let's consider all the functional groups we've looked at in this module and use their physical properties to see how we can distinguish the functional groups based on their physical properties. So first, a quick overview. Alkanes, we know, is a single bonds of carbon and hydrogens only. Anything less than 0.5 for organic chemistry is considered non-polar in terms of the dipole moment. So that's a very small dipole moment. So we can consider that they only have temporary dipole forces of attraction, making it a gas because of the low melting and boiling point, and it's not soluble in water because it's considered to be non-polar. Alkenes, very similar, still a fairly low dipole moment, so we consider it to be only temporary dipole forces of attraction, so it's also a gas, not very soluble in water. Haloalkanes, they are polar for most of them, although you can, of course, get the symmetrically arranged ones if they only got chlorine around it. Then it's got that dipole moment for those that don't, like in this particular one. So we have the temporary dipole and the permanent dipole force of attraction for most of them, but as I say, carbon tetrachloride won't have. It does, though, have a higher melting and boiling point because of those permanent dipole forces of attraction. So it tends to be a liquid in most cases. This is the smallest one, and with the fluorine. But most of them are liquids, and they're not particularly soluble in water because they don't form hydrogen bonds with the water. The alcohols do form hydrogen bonds, even though it's got a smaller dipole moment, so the permanent dipole forces of attraction are not as strong. It can form hydrogen bonds, therefore it takes more energy to melt and boil, so it's also liquid, and it is totally soluble in water. Amines, very similar to the alcohols because they have got all three different types of intermolecular forces, and so they are liquids and they are soluble in water and they form a basic solution. Aldehydes can't form hydrogen bonds because that hydrogen is not directly linked to the oxygen, it is bonded to the carbon. So it is similar to the haloalkanes in that it has only the temporary and the permanent dipole forces of attraction, and therefore are still liquids because they've got a high enough boiling and melting point. They are soluble in water, though, for the short-chained aldehydes because water can hydrogen bond with the oxygen of the aldehyde. So they are soluble. The same thing with ketones. So you'll see it's temporary and permanent forces of attraction. It is a liquid and it is miscible for the short-chained. Amides, notice this very big dipole moment, and that's for reasons you don't have to know, but there's a very big charge separation there. So we have the hydrogen bonding, but it's that strong permanent dipole forces of attraction that gives it a really high boiling point. So it's a solid. It's the only one that's a solid. And the short-chained ones will dissolve in water because of the hydrogen bonding. Carboxylic acids got a lower dipole moment, but it can form hydrogen bonds, and therefore it's got a higher boiling point, and it is soluble in water, and it does form an acidic solution. Esters, very similar to carboxylic acids, except it cannot form hydrogen bonds because there's no hydrogen attached to the oxygen. It is a liquid. This molecule can dissolve in water, but all other esters can't because the alkyl chain is too much, so it's more non-polar. It just can't form enough hydrogen bonds to be able to, or water can't form enough hydrogen bonds with the ester to be able to dissolve in the water. Acyl chlorides, very similar to esters in that they can't form hydrogen bonds directly, so they have similar melting and boiling points. The difference is that it reacts with water. So it reacts quite violently, giving off HCl gas and forms carboxylic acid. So therefore, it's an acidic solution. So how can we use all this information? If it's a solid, you've probably got an amide. If it's a gas, you've probably got an alkane or an alkene. If it's a liquid, it could be any of the others. So let's use the other physical properties. And the first thing you do is you put the substance into water to see if it'll dissolve. So if there's three possibilities: it doesn't dissolve, it dissolves, or it explodes. It doesn't really explode, but you can see it has a vigorous reaction with a gas being released if it's an acyl chloride. If it doesn't dissolve, it's got two options. It either sinks or it floats on the water. The haloalkanes tend to sink, most of them, and the others will all float on water because they are less dense than water. And you can distinguish an alkene by a chemical test, which you will learn in the next module. If it dissolves, you've got two options. You've got litmus paper, which can either turn blue or red. So if it's red, carboxylic acid, or blue if it's an amine. And of course, the third option actually is it doesn't change at all. And these we can distinguish further with chemical tests, which you will learn in the next module. Just in case you're wondering why we've got aldehydes or ketones, is the longer chained aldehydes or ketones tend to be insoluble. The shorter chained ones do tend to be soluble. So I hope you can work out the different types of functional groups based on their properties. Kia ora.